In this video, we are going to solve numerical based on Venturimeter, where we will calculate absolute pressure at neck of Venturimeter, and also we will find discharge of liquid flowing through Venturimeter. So the statement is given as a Venturimeter 100 by 50 mm size is used to measure the flow of liquid of specific gravity 0.8. If the mercury differential manometer head is 200 mm, find discharge through the Venturimeter. Also find absolute pressure at the neck if the pressure at the enlarged end is 0.5 kg per centimeter square. Take CD equal to 0.98. To solve this problem, first I will write down the given data provided, where inlet diameter of Venturimeter is given as 100 mm, that is 0.1 meter, which is denoted as small d1. And the throat diameter of Venturimeter is given as 50 mm, that is 0.05 meter, and it is denoted as small d2. And specific gravity of oil flowing through Venturimeter is given as 0.8. Here mercury differential manometer is used, which shows reading of 200 mm, that is x equal to 0.2 meter of Hg, that is mercury, and the value of CD, that is coefficient of discharge, is given as 0.98. In this problem, first we want to calculate discharge of oil flowing through horizontal Venturimeter and the formula of discharge which we had derived in previous video. So by using that formula, we will calculate actual discharge of Venturimeter. In this formula, the value of coefficient of discharge, that is CD, has already given in problem as 0.98. Here A1 and A2 are the areas of inlet and throat of Venturimeter which we'll need to calculate. So we know that area equal to pi by 4 diameter square, and the values of diameters of inlet and throat of Venturimeter has given in problem. Hence A1 will be pi by 4 d1 square, that is 0.1 square, and A2 will be pi by 4 d2 square, that is 0.05 square. And also we have to calculate small h, which is the difference in pressure head at inlet and throat of Venturimeter. So the formula of small h will be x into specific gravity of heavier fluid upon specific gravity of lighter fluid flowing through Venturimeter minus 1. Here small x is given as 0.2 meter, and here heavier liquid is mercury, so its specific gravity is 13.6, and the value of specific gravity of lighter liquid, that is oil, is given as 0.8. So by using these values, we will calculate small h equal to 3.2 meter of oil. Now I will put this calculated value of small h in discharge formula, and here small g is acceleration due to gravity, which is 9.81. So now we have found all the values in formula in order to calculate discharge. Therefore, by calculating this, the discharge of oil flowing through the Venturimeter equal to 0.01574 meter cube per second, that is equal to 15.74 liter per second. Next we want to calculate absolute pressure at neck. If the pressure at the enlarged end is 0.5 kg per centimeter square, and we know that absolute pressure equal to atmospheric pressure, that is 101.3 kilopascal, plus gauge pressure. So to calculate absolute pressure at the neck, first we need to calculate gauge pressure at neck. So we can calculate gauge pressure at neck with the help of another small h formula, because the value of small h we have already calculated 3.2 meter of oil. Therefore, the another formula of small h will be pressure head at section 1, that is P1 upon rho g, plus potential head at section 1, that is Z1, minus pressure head at section 2, that is P2 upon rho g, plus potential head at section 2, that is Z2. Here P2 is the gauge pressure at neck which we have to calculate. Therefore, after simplifying this equation, we will get the equation. I will put small h value, that is 3.2, equal to P1 minus P2 upon rho g minus Z2 minus Z1. Here, since Venturimeter is installed horizontally. Hence Z2 minus Z1 equal to 0. Here P1 is the gauge pressure at section 1, that is pressure at inlet, which is given in problem as 0.5 kg per centimeter square. So I will convert this value in kilonewton per meter square and I will put this value in equation. And here rho is the density of oil flowing through the Venturimeter, which we will need to calculate. So in problem, specific gravity of oil is given as 0.8 and we know that specific gravity of liquid equal to density of that liquid, that is oil, upon density of an ideal liquid, that is water. So here density of water is 1000. Therefore, we will calculate density of oil as 800 kg per meter cube. So I will put this value in the equation. And here small g is acceleration due to gravity, which is 9.81. Therefore, by calculating this, I will get P2, that is gauge pressure at neck, as minus 25.06 kilonewton per meter square. Here negative sign indicates the vacuum pressure. Now with this calculated value of P2, that is gauge pressure at neck, I will calculate absolute pressure at neck. Therefore, we got absolute pressure at neck as 126.36 kilonewton per meter square, or also known as kilopascal.